Just wait a moment for them. While you wait, just pull up Onshape, log in, open up your document where you have your parts from last week. If you have any questions at the beginning, that was a good time to ask. I can pull up my own Onshape. Well, if you're in a car, you probably won't have an easy time doing CAD. So I trust you'll find a way to do what you can do. Let's see. Yeah, that's probably a good idea, Amy. Just whatever works, right? If you can follow along and like it doesn't affect you that much, if you have any questions live, you can still ask them while I'm here in person, virtually in person. Seems like we're not getting any more people, so let's get started. Hopefully by now you're back to where we left off at the end of class, where I believe everyone was able to get these parts modeled. And so first thing we do, same as we did 2 weeks ago when we first demonstrated assemblies, you'll observe that all of these parts are free to move. So I can click them and drag them. They're not constrained to any part of the assembly, right? It's like I just dumped the bag full of parts onto the ground. And so the first thing I want to do is, since the assembly has an origin point, I do kind of want to make sure my full assembly is sensibly located with respect to this origin. And that's just because maybe I'll use this assembly somewhere else, like maybe in a subassembly or as a subassembly for another assembly. And when I import that, the center, this is just kind of the center of the assembly. And likewise, maybe when I import the file somewhere, depending on the file type, it might consider this to be like the 000 point. And so I don't want that to be over here and my entire model to be somewhere else. And so first thing we want to do is fix the stand. Logically, it kind of makes sense for the stand to be fixed in the context of what this thing is. And so if you'll remember, we have our fasten mate for that. So see if you can do that same way we did before. Just take a corner of the stand and fasten it to the origin. And you'll get another chance to work with our mate connectors. So something like that. You'll see there's my first mate. And in the tree on the left, my list of all my mates, you'll see that I have this fastened here. I see a couple more people join since I started talking. I didn't really notice when you quite joined, but all we did so far is open up our assembly that we left off with last week and made our first move, which is to fasten the base just so that it stays still. And so as we go through this assembly, this is going to be our first sort of complicated assembly where we're going to have different types of mates. We're going to have a lot more mates than we did before when we were just fastening the bricks on top of each other. And so in general, when you're working on a project, it's good practice to name your mates, just because even more so than parts and features. It gets really confusing what mates are, like stand to ground. And so if you didn't know that, you can actually name all the parts. Everything in the feature tree, even in here, you're able to name. And so, especially when you work on like group projects and such, we're all working with the same CAD document. It's a good idea to kind of name things in your feature tree, but don't worry too much about that if it takes too much time for you. It's just a point that I like to make. So while I'm rambling, hopefully you caught up with that whenever you joined. Next thing we want to do is just like assembling this if we had the parts with us in real life. So let's say the next thing I want to do is attach this axle to the sprocket, right? And so what I do is I put it into the hole. I want it to be kind of symmetrical so that the axle is centered on the sprocket. And realistically, I kind of want them to be joined together, right? As if I were taking glue and applying the glue to the axle just so that it would rotate with the sprocket. And in real life, I probably wouldn't use glue because that's not a good way to transfer torque, but you can see in the demonstration model, there's a QA, which I brought up last week. And so we're just kind of mimicking the function of that QA, which is to lock things rotationally. And so since I'm using the word lock and like glue to suggest that we're going to use a fasten mate. And this is a bit different from what we've done before, since we kind of want this to be symmetrical instead of a like point-to-point kind of mate. You'll notice Onshape kind of has these default mate connectors. When I hover over my shaft here, you'll see by default there are 3 mate connectors, one on the top, one on the bottom, and one in the middle. So that's great. I want one in the middle because I want this to be symmetric. Let's say for some reason I didn't want it to be in the middle. I have my mate connector tool here. It's the second one in the whole toolbar. So I'm actually able to create custom mate connectors. I can like move it around and such, but I'm not going to do that just because I don't need to. But I'm sure for some of you, the first question that comes to your mind is, what if I don't want these 3? That's what you would do, but in my case, the middle is good. So there's my first mate connector. And as you know, for the fasten, you need 2 mate connectors. The second one is in this sprocket. And I kind of want it to be in the middle as well, right? So this thing ends up symmetric. So what I'll kind of do is align my camera so I can kind of look into this bore in the sprocket, this hole. And you can see if I look really closely, this one also has 3 mate connectors. One in the front side, one in the opposing back side, and one in the middle. Might be kind of hard to tell like 3-dimensionally, but as I move my mouse here, this mate connector is located on the plane that kind of bisects the sprocket. So I click on that. Onshape solves it, and you'll see that now it moves to where I want it to be. So that's a fastening complete. You can see when I move one, the other one moves with it. They're functionally just bonded together now. If you had any problem with that, ask a question. If not, I'll assume everyone's good. All right. So now there's kind of 2 ways we could go. We can either put this thing that we just made into the stand. We could also put the handle on. Maybe for me, I'd like to put this on the stand. That seems pretty interesting. And so how do we want these things to behave with respect to each other? Well, we don't exactly want to fasten them anymore, because if we did that, it would be kind of like we're gluing them together, right? And so there would be no motion possible if we fasten them, and that's not really the intent. That's not the design intent, where we kind of want that handle to be able to rotate the sprocket. So we're gonna have to use a different kind of mate. I see if you have your hand raised, you have a question?
I was just thinking about it. Like, which one is the axle again?
This is the axle. I've also called it like the shaft, or.
Which one's the linkage then?
That'd be this one.
Doesn't the linkage have 2 holes inside? Or does it have 1?
It doesn't really matter. As I've said a couple times, this isn't really realistic. This isn't like the way that you would make this if you were like woodworking or metalworking, but just for the purposes of our CAD, it'll work either way. If you had no holes, it would still work, just because we have our mates, which are kind of these ideal geometric relationships. So it doesn't really matter. It's up to you whether or not you have the holes. Should work, whether you have 2 or 1 or none. All right. So next thing we want to do, I guess next thing I will introduce is the second mate. You'll see that it is actually the second one in the toolbar. We've used fasten, now it's revolute. And so let's see what it does. We click on it, brings up the same tool, and you'll see it still asks for mate connectors. So it's pretty much the same thing that we've done, just that it will end up behaving a bit differently. And so what's my intent here? I kind of want to put this axle, the shaft, inside of these 2 holes, the bearings. And I want it to be symmetric again. So what I'll do for my first mate connector, I want it to be kind of in the same place that I just put it. So it'll be kind of hard to see now that the sprocket's in the way, but what you can do is hover your mouse over this piece. And if you just move your mouse a bit, you'll see the mate connector moves as you come closer to one or the other. So you should just be able to select one like that. So you can see that's where my mate connector is right there. And for the second one, you can imagine where I would want my mate connector is to be right in the middle here, between this hole and this hole. But you can see Onshape doesn't like intuit that, right? It doesn't know what I want. So what I can do is I can create a mate connector using the mate connector tool. There's a few ways I can approach it. I'll show you one of them. If you're unmuted and you don't have a question, I'd ask you to mute. So how are we going to do this? We have our mate connector tool. That's the one right over here. And it allows you to just create a mate connector. So the way this works, it's kind of like selecting a mate connector for a mate, but you see if I click kind of generally where I want it to be, you can see where the mate connector is. Amy, would you mind muting your microphone? Thank you. And so you can see this where the mate connector is. This is almost where I want it, but not quite. It's on the right axis in terms of the cylinder, but it's not in the right location along that axis. And what I can do is just tell it to move. Yeah, no problem. I can tell it to move using this move tick box. And you'll see I can specify a direction along which to move it. So in this case, perhaps I would need to know the distance between these two. I think from memory, it might have been like an inch or something. But you can see what happens. I guess it was not an inch, but must have been 3/4 of an inch. So you can see that's one way I can do this, right? I created my mate connector. Don't worry if you missed that, I'll be coming back to it, but I have this mate connector now that I can use for another mate, where I can now select this as one of my mate connectors. You might think, oh, what you just did, that wasn't very robust, right? If I change the stand, it's not going to change together. And you're right. If I update the size of my stand, the mate connector is still going to stay like 3/8 of an inch away from this face, which is not great. And so you can see now I have another option. We have on entity by default, but if you click this little triangle, you have an option for between entities. And hopefully if this tool works the way I think it does, as always, we're doing this live. I select 2 faces. Okay, let's try that again. And as you can see, this tool perhaps does not work the way that I expect it to work. And that's fine. That's how we learn things in CAD and in life. So what we'll do is go back to the way that we had it before. I'll select that. I'll change back from between entities to on entities. If you're really curious about what between entities does, I'd recommend you look it up. Onshape has a pretty good documentation. Unfortunately, I don't have a measuring point 3. Right, so I'll pause for a moment there. That was kind of a bit of rambling, but hopefully you're able to follow that. I expect probably you might have some questions about creating this mate connector, but feel free to ask. All right, great. I'm glad my explanation was great. So in any case, that's how you create a mate connector. If you really want it to be robust, you can use what's called variables, which we go over in a later CAD class, but there are ways to make it robust, even if the tools that you see don't exactly work the way you thought they do. So back to where we were trying to use the Revolute mate. And so let's go back to that, open it up, tools active, Windows open. Here it is. So for my first mate connector, I want to hover over the axle, kind of bring the mate connector down to the center. You can see it might be a bit finicky, but with a bit of practice, you should be able to get them. The second one, just select the mate connector that we just added manually. And if all goes well, it'll kind of solve, or it might not solve, but it'll move over to where it should be, right? And you'll notice that the sprocket didn't come with it. And that's just because Onshape hasn't solved it. It hasn't gone through every single other interaction and figured out where everything should render. It just moved the most immediate entities involved. If I click solve here, hopefully Onshape goes back and checks all the interactions. It sees that the sprocket should be fastened to the shaft, so it moves the sprocket too. So now we're good, right? Looks pretty good to me. I'll click the check mark. And that seems to be what I wanted it to do. So that step is finished. It's probably one of the more challenging steps in this whole process. So if you have any problems with that, speak up. You can also hide the mate connector once I'm done with it, just like I could for sketches and parts. All right. Is anyone not able to get to this step?
Wait, when I moved it only moved the axle. It didn't move the sprocket.
So if you're still in the window, like if you haven't accepted the mate yet, you might see a button that says solve. If you do, click that button and hopefully it'll update. And even if you don't click solve, if you click the green check mark to finish the mate, it'll probably snap into place. And if you've accepted the mate and it's all like, it looks like what I have right now, and the sprocket doesn't move, that's probably an issue with your fastened mate.
Excuse me,
Yes.
but how did you manage that the tube in between that, whatever that thing is?
In the stand?
No, I
With the
don't get
axle?
how you can get the tube to like go between these two.
This and this?
Yeah.
Right. So unfortunately, there's not a rollback bar, so I can't just go back. But the mate that's involved there is the Revolut mate that we just did. So I guess I'll show that again since it seems like more than one person is on that step. So this is the new mate that we're introducing. It's called Revolut. It's the second one in the list right after fasten. And so we're able to create the mate connector. This thing right here. I'll take your silence as an agreement.
I really can't talk that much because my throat hurts. A little bit.
I didn't understand what you said.
I can't talk that much because my throat hurts whenever I talk.
Oh, that sucks.
Okay.
Let's move on.
I'm not sure what the situation is, but if you have the mate connector for the Revolut,
Yeah, I accidentally deleted, so I'm just running on watching.
sorry, I'm not making out like all the.
No, I'm just watching because I forgot where I put the slide, so I can't find it.
In terms of the slides, I don't think these slides are posted on the classroom or anything, but I take it to mean that you're just like watching the class, which is fine, I guess. I think the student who's on the car is also doing that, so it's up to you, I suppose. But yeah, if you have any questions, just feel free to keep asking as you have. For now, I'll just slowly demonstrate the Revolut again. I select the first mate connector in the center of the axle here. And the second one, I just select this mate connector that I created manually. One thing that you might observe is when you first click on it, only the axle moves. And so this is just a visual thing. Onshape doesn't take the time to check every single mate and update it visually whenever you click on whenever you first like create the mate, right? So if you want to see what happens, you can click solve and Onshape will update everything. But even if you don't click solve, if you click the green check mark, it will update. So hopefully the other person who had that question has been able to resolve it by this point. If not, I hope they will ask again. But you'll see what the Revolut does, kind of as its name might suggest. It allows revolution, rotation, So I don't know if you can see it that well through a zoom, but I am able to spin the sprocket inside of the stand just by clicking and dragging. Another way you can visualize what your mates are doing is using an animation. So if you right click on a mate in this tree here, you'll see one of the options, third from the bottom, is animate. So this comes up, there's a whole bunch of options. The main thing in this case, I wanted to loop because it's circular. And the number of steps just determines like how fast it goes, essentially. So if I put in a number like that, you can see, hopefully with a slower rate, you can actually see it through zoom. But
How did you do that?
so if you're asking about the animation, I'm not sure, based on what you said of your situation, I'm not sure if you're on Onshape.
I'm on shape. I'm just curious, how did you rotate this?
So the rotation is enabled by the revolute mate, right? So up till now, we've been using the fasten mate. And so the way I've talked about that is in terms of like gluing things together, fastening them, locking them in place. And so the revolute mate is our second type of mate. And it's different in that it allows you to have 1 degree of freedom. So all of these mates, the purpose of all of these mates is to determine how our different parts are located with respect to each other and how they're allowed to move with respect to each other. And so you've seen like the fasten tells you the location of 2 parts with respect to each other, and it just locks those in place. Well, revolute also determines like the motion of the parts relative to each other. So when I revolute this axle to the stand, I'm telling it that in the direction of my mate connector that I created, which is along this this y-axis in the full assemblies context, it has a degree of freedom there. So it's allowed to move, which means that it can rotate. And so that's what the revolute mate kind of does. You can see kind of in the icon, it sort of tries to explain what it does by having these arrows. You can imagine for like a cylindrical component, the revolute mate, it locks it into a position, but it doesn't fix its angle. So it can still freely rotate. And this is very useful, as you can imagine, for things like modeling wheels, modeling gears, anything that spins. Now, specifically for the animation, the way that I did that was right clicking. And if I click animate in that window, it brings up a bunch of options. All I did was change that to loop. And if I play it, all it does is it shows every single possible position that this mate allows, right?
Okay.
The mate allows rotation, which is 360 degrees. And so all it does is it just goes through every single position that this mate allows with its 1 degree of freedom. And you can even see like the current value of the mate. It's in degrees right here, right? 212, 230, 250, 260, and so on. So to all students, I hope it works. I hope you don't have any problems with making the mates, but if you are, just know that mates are often very finicky part of CAD. They don't always work the way you expect them to. They often break for unexplainable reasons, but all you can do is persevere. So are there any other questions up to this point?
The animate thing,
Yes.
how'd you do it?
So in the mate tree here, in the list of mates we have, the mate that allows motion right now is revolute. And so I know that. And so if I right click on that mate, you can see this window comes up, this, and towards the bottom here, there's an option called animate. So if you click that, by default, it'll be on reciprocate, just to show you what that does. It's kind of like a reciprocating motion. So it'll complete 1 full circle, and then it'll go backwards, and then it'll go forwards, and then it'll go backwards. The way you can speed it up is just reduce the number of steps. So this will make it 3 times faster. It's just showing fewer steps. So it's essentially just a speed up. You can see what the reciprocate does. It just flips back and forth. There's also single, which will just do it once. In this case, what makes most sense is probably loop, just because we do want it to keep going in the same direction. So that's that. Animation isn't too important unless you're doing like a concept demonstration. Maybe you're a designer and you want to show off what you have, make some renders. In that case, you'll probably be doing some kind of motion study where you'll be animating multiple mates at the same time. So here we are. We're almost done. We just have these 2 parts left that we haven't used. First, we have our linkage here, which, as someone pointed out, it's really up to you how you make this. It could actually just be a rectangle, and that's totally fine, since we know how to use mate connectors now to allow us to do what we need. So let's start off by thinking about how these 2 things should attach. And this is another place where perhaps in real life we wouldn't design things this way, but since it's CAD, we can kind of get away with it. Since this is a crank handle, we want to make sure the sprocket moves along with the handle. So relative to each other, the handle and the sprocket shouldn't be moving. And that means we want them to be fastened. So we're doing it again. See if you can figure out how to set the mate connectors up yourself. In this case, you don't need to make a manual one. You can just use the ones that Onshape can intuit. For me, I think I'll just go with the one on the end here. And I'll pick the one on the end here. What happens is the circles get locked together. Click the check mark. You'll see now they're attached. What you can see is now it behaves the way I want it to, where I can turn the sprocket using the handle. And again, if I animate it, there you go. So I'll wait just a moment for you to make that fastened mate. See if you can figure out how to do the handle too by yourself. It's pretty much the same concept now. We kind of want to glue the handle to the edge of the linkage. So we're going to use another fasten mate. And let's see in this case if Onshape is smart enough to guess where my mate connector should be. Spoiler, I guess. Onshape can do it. And that's kind of because the way that I created this object, I made sure this is a circular arc. And so whenever there are circular arcs, like there is right here at the end, the center of that arc will be automatically kind of like included in the likely mate connector points. And so that's great for me. That's what I want. I'll select that as my first mate connector. And for the second one, I'll just pick the base of the handle, like so. And that looks good to me. I'll click the green check mark. And with that, I'm done with my assembly. That's all I really needed. That's all I have. The show's pretty much over. So I'll wait again just for questions if you have them. You can admire your handiwork. If you want, you can hide the origin and the other things. Wow. Wow, indeed. If you're an aesthetic person, you can go back and change the colors of your parts too. I don't know. I'm not great with colors, but whatever floats your boat. The way you change the color, you go back into the part. If you right click on the part here, you'll see the fourth option is edit appearance. And what you can do is just pick a color. And it's mostly just for visualization. It doesn't change anything about the model. If I go back into the assembly, you'll see, hopefully it updates. Yeah, there you go. Bright and colorful. So no one's asked me any questions, so I assume you're all at the same place. For those of you who are able to CAD currently, which is pretty good. First learning assembly is pretty challenging, I suppose. So you've made your first steps now. And where do we go from here? So this whole process took, I see a question actually. Reminds me of McDonald's colors. That was not intentional, but I suppose like the red and yellow, I can see that. So we've made one thing, and what is there to do but make another thing, right? Of the projects that this class has done in the past, just as a reminder, it's my first time teaching this class. The second kind of project that involves assembly is this device, colloquially called the do nothing machine. Thank you for that, by the way, in the chat. But it might be kind of hard to visualize what this does, but it's a form of kinematic machine, right? So hopefully if you have a good mechanical or physical intuition, you can imagine that this knob here is intended for a person to hold. And so if you move the knob around, you'll think that these blocks, these trapezoidal blocks, can slide along their grooves. And so they slide in just the right way that you can maintain a kind of circular motion by having these blocks slide around their channels. So it might be hard to visualize the way it is, but the idea is for the next part of the class, we'll just focus on making that. And towards the end, if we have time, I'll talk a bit about 3D printing. It's my email. We'll talk about 3D printing. So see if your hand raised. Do you have a question? Tony. Since you don't seem to have a question, I'll.
Oh wait, what was that other thing? Was that like a phone stand? Like that thing?
This?
Yeah.
Yeah, it's some sort of phone stand. I've seen things like this before. Let's see. Yeah, some sort of phone stand. I imagine it's a very common and over-designed type of product where everyone has their own version. And this is a house, as hopefully most of you have recognized. But these are just single parts, so they're better exercises in terms of like sketching and figuring out how to extrude things in different angles. Not even different angles, actually. All of these things can be made from single extrusions put together. So if you're motivated, if you want to learn, sure, go for it on your own time, or maybe on our time if you're very fast at doing the things that we do together. But the next thing we're going to do is try to make this. So again, I'd recommend making a new document, new assembly, new document. I'll call it the do nothing machine, I suppose. And here we go, fresh start, new part studios, new assemblies. And so I'll go into the same thing that we did last time, talking about like what shapes do you see, how are you going to make this thing. But before I do, I just kind of want to show you this website. I guess I'll copy the link for you too. It's kind of a virtual library of Cornell's collection of kinematic machines. So there's this guy named Rouleau who was a person who studied these things. He studied the motion that can be produced by different mechanical parts. And there's all kinds of machines that he made. So simple ones are like slider cranks. You can see each of those links is kind of a different directory of classes of machines. And so there are some videos here of machines at play, but maybe in crank mechanisms. This is probably a better illustration. So you can imagine that as you create these relatively simple machines using simple parts, all you have are like rectangles, pins, and a slot and pin, right? And so with relatively simple parts, you can actually create very complex motions just by the way that these things are geometrically related. So on your own time, just if you're interested in this kind of thing, which I kind of am, you can go through, look at them. A lot of them have videos associated with them, which is cool. And so this is kind of like a class of those machines, right? It's a very simple one linkage device. So while we're here, I'll open the floor by saying, what shapes do you see? I'll bring it to the front so you can actually see it. There you go. What shapes do you see?
Square,
Where do you see a square?
the base.
Base. Sure, I buy it. What else?
Quadrants. So another square is on top. Kind of,
These?
yeah.
Okay, yeah. And you'll notice the edges aren't really flat or straight. So that might be something interesting. What about some of the other parts? What do we see? Maybe in terms of features that you might use an on-shape.
Like the circles for the handle,
Yeah, sure.
like the 3-point one.
Yeah, like the sketch tool where there's different ways to draw circles. That might come into play. So, like with that arc there too, yeah. And what about like this groove? What shape is that? Sort of like a dovetail in woodworking. What's it called? Great question. I guess I'll spare you the well, okay. Well, I think it's sort of like a trapezoid, right? And you can see that the block that slides in the groove is trapezoidally shaped. Could be a triangle, something along those lines. Then we have our link here, which is basically a rectangle, but the ends are rounded off and there's 2 holes in them. The whole thing.
What's this whole entire, yeah, like that.
Assembly called?
Yeah.
I don't know if this particular one has a name. It probably does, actually. I'm sure it does. I'll leave it as an exercise for you to find out because I do not have it on the top of my head. I think it's named after somebody, ancient Greeks or something of that nature. So we'll start off just with our part studios. We identified all the parts we have. So there's a base here. There's these trapezoidal sliders, there's a link and there's a handle. So how many distinct parts? 1, 2, 3, 4. So just go ahead and create those. We want a base, we want sliders. We want a linkage. And what was the last one? The handle. And our assembly, which is just there by default. So we'll get to that last. So starting off, since we don't have that much time, how many classes do we have? I think this is week 6, so we do have just 2 weeks after this. So I think we'll finish. Shouldn't be too bad. I'll just get it started. Someone said the base looks like a square, which I agree with. It's symmetric by 90 degrees. So let's start out with that. We make a square with that corner rectangle tool. I suppose if you're someone who cares a lot about part and assembly origins, you can make the square centered, which in some cases might make more sense, but I'm not too worried about that right now. Next thing, condition for a square is that they have equal sides. So I can do that with constraint. Last thing, why isn't this fully dimensioned yet? It's because there's no dimensions. So I'll just add one with the dimension tool. And this number will determine the size of this entire object. Let's say 2 inches. It'll be miniature. So that's a square. The next thing we'll probably do is to extrude the square. It's been a classic move. So we've done most of the work now. We just need to cut out these grooves. And we need to round out the edges here. So we'll do that. We're gonna have to make a sketch for the grooves, right? And you can imagine the way we might go about doing these grooves perhaps is to cut out the shape of the trapezoid that will be sliding along it. So if we look in one of the orthogonal directions, maybe the front, I can then sketch on the front plane. You can see the outline of my sketch there. And what I'll do is I'll draw the shape that I want, which is trapezoid. I drew it up in the air, but that's just because I was trying to make a point that I can make a better way. So I made the sketch and right now there's nothing in it. If I hide the part that we already extruded, you'll see clearly there's nothing in the sketch, right? But I don't want to make this sketch from scratch. I kind of want to have it be in a logical place with respect to this block that I already have. And so one way that I can incorporate this block is by just clicking on parts of it, right? So what I've done before is I've hovered over the geometry, and you'll note that when I do that, Onshape will create some constraints just based on this part itself, even though that's not actually in the sketch. So that's pretty useful. While we're here, I'll teach you a new tool though, which is this one here called project or use or convert. So what this allows you to do, if I click the tool, it essentially allows you to bring anything that's not in the sketch, but still exists in your part studio. And it allows you to bring that into your sketch as just lines and arcs and splines and points and such. So to demonstrate what I mean, if I have this tool active and I click on this rectangle, you can see that it brings the rectangle into my sketch. So even if I hide the part now, that rectangle is now part of my sketch. So that's one way that you can bring in kind of references to other parts. And if I update the size of my extrusion, if I make this like 3/8 of an inch, and I go back to my sketch, you can see that the rectangle updated. So that's pretty useful sometimes. Of course, I don't actually want, in this case, the entire rectangle to be an actual thing. So if I hit Q, as you might recall, that creates construction lines. And so I've done that, and now I have these lines that I can work with in my sketch. So I've done all of that. What else is there to do? I have to make my trapezoid. So one thing I know about my trapezoid is that I want it to be centered. So I'll use the kind of snap constraints, where if I hover over the right place, you can see that little box comes up right there. And that means midpoint. And since I want my trapezoid to be in the center, that's probably a good place to put a line. So I'll draw a line like that, make sure it's vertical, and it'll be black except for the bottom point. I'll make this also a construction line. And now I'm almost done. I just need to draw the actual trapezoid part of this whole thing. We'll start off with something like that. I'll make the base of it horizontal using the horizontal constraint. And last, I just need some dimensions, which can really be anything. How about 3/8? So there you go, that's half the trapezoid. For the other half, we'll use the mirror tool, which I forget if we covered in this class, but it's pretty straightforward. It's simpler than the feature pattern for sure. The way it works, if you select the mirror tool, it asks you to select a mirror line. And so that's just where the mirror would be. If you think about a real life mirror, it's the line of symmetry. In my case, I'll just use that line. And once you click a line of mirror, it asks you to select entities to be mirrored. In my case, unfortunately, I cannot select. You can see like there's a shorter line segment that I'm trying to select, but I can't click it because of my construction lines in the way. One thing you can do is right click. Whenever you have a situation like that, you can right click and select other. And so now it brings up this window where I'm not sure if that actually selected it, but right, I think it did select it because you can see it over here. So I'll do that again just because it's a new tool and all. We have our mirror tool, select a mirror line. As you select entities to be mirrored, you'll see it just automatically starts drawing them. There's that. And I want to select that line segment that's kind of hidden there. So just right click, select other, and this is the one I want. You can see it's highlighted, and if I click it, you can see it finishes that off. And with that, I've sketched a trapezoid here. You can see it highlighted. And the next thing I'll want to do is cut through the entire block in that shape. So hopefully this just works. I foresee that perhaps if Onshape does not like the fact that I'm extruding up to the edge, it might cause a problem, but we'll find out. So we bring up our extrusion. We change add to remove. What is the dimension of the bottom line? Doesn't matter, it's up to you. Just make it look sort of reasonable. Just like with the other thing, with the sprocket machine, we're just making things up here. I'll change the extent to through all. And fortunately, Onshape can handle it. It's pretty good. I'd expect no less of a competent CAD package. And with that, I've created my first groove. If you have any questions, ask. If not, we're basically going to do the same thing on this side. All right, seems like no questions. So we could do the same thing again where we draw a sketch, this time on the right plane, make the trapezoid, extrude cut it, and that's all fine. Another thing we could potentially do is use a circular pattern for a feature. I'm not sure if there's an easy way to select that axis, but we can also just draw another sketch and do it that way. So I'll leave it up to you in terms of how you want to do this. Let me see if it, so there's no easy axis to snap to, but we can fix that just by doing another sketch. And because this might be slightly faster, I guess I'll do it that way. So I'll make another sketch, this time from the top. And the objective here is just to create a center point for this circular pattern that we're about to do. I believe Onshape will accept a point in a plane as an axis for a sketch pattern, though I'm not entirely sure. If not, it'll probably accept a circle. So what I did just there was very carefully allowing Onshape to guess the constraints that I wanted. So you can see just by default, it's vertical to this line, this point, horizontal to this point, so it's all black. If you don't want to mess around with that, just dimension it normally, which I trust you were able to do. So you can see now I created the sketch, I have this point, and hopefully it'll let me just circularly pattern my feature, this extrusion, about this point. And it does not. So what I do now, go back to the sketch, maybe it'll take a circle as an axis. Again, as with all CAD, and you'll go through this whenever you learn a new CAD program, you never know what you can and can't do until you try it. So I'll make a circle just like that. Hopefully it works. If it doesn't, we'll just have to make another sketch on this side with the trapezoid and extrude it. But fingers crossed. We want to feature pattern the extrusion about the circle, and it works. So pray for us. And with that, I've gotten what I want. I see there's a chat message, cannot remove the trapezoid. I assume we talked about the extrude cut. I'll take a brief moment here to note that it is 8:15. So in terms of parting words, just hold on to this document. We'll come back and do the other parts and assemble it, hopefully by the end of class, and also potentially talk about 3D printers if you are so interested. Other than that, that's all I have for you. I'll stick around to answer questions for another moment or two. And the question I'll start with is the one that just came up, which is not being able to remove the trapezoid. So you're on this step right here. And it says, actually, I'm not sure if it's on this step or on the last step. Which trapezoid can't you remove? Is it the first one or the second one? To whoever asked. The first, okay. Does it go part of the way? If it does, I'll go through all another possibility is that it's trying to extrude the other way, in which case the targeting tools don't intersect because it's trying to cut thin air. The way to fix that is just point it in the other direction. And if it's not that, okay, it is that, that's great. If it's not that, it's probably an issue with the sketch where a lot of times with CAD, if you do things with the edge, sometimes it gets concerned about zero thickness or infinitely sharp intersections or whatever, infinitely thin walls and such. If that happens, just what I would do is just extend the sketch a little bit, just so it cuts beyond, and that should fix things up. But in our case, it just works as it should. This isn't that weird of a thing to be doing. I might show the pattern thing again at the start of next class, so don't worry about that. Okay, goodbye.